as we approach the closest point of 3I Atlas to Earth on December 22nd. This peculiar object continues to present us with deeper mysteries. The intriguing aspect here is that we are uncovering more anomalies rather than eliminating them. It's simply not possible. We recently identified another anomaly, number 16. I must emphasize that we've received fresh and significant information about 3I Atlas, and trust me, this is far from a trivial detail. It concerns the object's spin axis. Although we covered this in the previous video, it's essential to revisit it as there's something crucial I want you to pay attention to, alright? We're discussing the spin axis of the object, which relates to how it is oriented during rotation. This raises another uncanny issue that would be quite improbable if this were merely a typical comet. That demonstrates how significant this is. Let me guide you through this with care. Even though the idea may seem technical, it's actually quite straightforward once you visualize it. I'll present you with a graph that illustrates the antitail jet's direction over time. In this context, the term antitail refers to a thin feature that looks like it points towards the sun in the image. The crucial measure here is the position angle. Basically, it indicates the direction of the line in the sky. Think of it as using a compass in the celestial sphere. They assess the antitail direction at a projected distance of 6,000 kilometers from the brightest section of 3I Atlas, which is roughly equivalent to 3,700 miles. They synchronize the measurements, meaning they merged the data into a continuous cycle, akin to compressing numerous days of observations into a repeating clock. Thus, they discovered this periodic wobble that we've mentioned, with a cycle time of 7.74 hours. Essentially, this means the object completes a full rotation around its axis every 7.7 hours. The red horizontal line you're seeing in the image represents the average direction of the jet angles. That average direction reveals the sky-projected orientation of the rotation axis. So what does this new study suggest? It implies something quite specific. The base of the jets is offset by less than 8 degrees from the object's poles. This is peculiar and significant because it suggests the jet is emanating from a region close to the top or bottom of interstellar object 3I Atlas near the spin pole, similar to our Earth. As the object rotates, the jet undergoes precession. In this scenario, precessing means the jet doesn't point in a perfectly fixed manner. It traces a slight cone motion like a spinning top that wobbles during its spin. That's why we refer to it as wobbling. Picture a spinning object, a jet positioned near the pole, with the jet's direction oscillating in a small cone. A crucial point is that this wobble is minimal, less than 8 degrees. So visualize the object and the jet, followed by this oscillation. The primary inference here involves what we might term the consistent day and night sides. What does that imply? It is a logical deduction based on the discussed geometry. Far from the sun, 3I Atlas is now moving away from the sun, correct? It has a steady day side and a steady night side. This means one hemisphere predominantly faces the sun while the other remains mostly dark. Such a configuration occurs if the spin axis aligns with the sun's direction. Rather than both hemispheres receiving sunlight during a rotation, one side tends to be primarily sunlit while the other is mostly within darkness. Normally, those roles would exchange positions during perihelion. So why does this count as yet another anomaly? Harvard's Professor Avi Low labels it the 14th anomaly, while we have the 16th due to anomalies noted by various scientists. Now, if the jet behavior stemmed from natural cometary activity, like a cache of ice releasing gas upon sunlight exposure, this geometry still presents a new anomaly. Why? Because the spin axis is closely aligned with the sun's direction, staying within a mere 8 degrees angle, which strikes us as unlikely. This alignment even occurred while 3I Atlas was still distanced from the sun, beyond $5 in heliocentric distance. For reference, $1, the Earth's distance from the sun, is approximately 93 million miles, which means $5 is around 465 million miles. Thus, even at such a distant location, the spin axis aligns with the sun's direction as if it is particularly seeking that alignment. Avi has calculated the statistical probability of this occurrence happening naturally as just 0.5%. That's 1 in 200. Next, we need to consider how a misalignment would appear. What if the spin axis wasn't properly aligned? In that case, the antitail jet would be at a more pronounced angle relative to the spin axis. However, that is not the case. The two align almost perfectly, which is indeed odd. Also, with a worse alignment, the jet might display gaps, but it doesn't exhibit such gaps. Why would there be gaps? Logically, because the source region would rotate into darkness, lose sunlight, and shut off, subsequently rotating back into daylight, leading to activation. If you were operating a spacecraft, you would want continuous jets, right? especially since the object altered its trajectory towards Jupiter during its perihelion. This situation presents yet another anomaly, which is incredibly fascinating. I'm not asserting one theory over another. You'll have to judge for yourself. Hopefully, the forthcoming data will provide more insights. Essentially, the fact that this alignment remains narrow and stable indicates a special geometry. Let's refer to it as special geometry. We're not suggesting this was constructed by someone. Look at this multi-panel image filled with arrows and lines. What do we see here? These panels depict the interstellar object 3I Atlas. The slender purple lines indicate the measured angle of the anti-tail position at 6,000 kilometers from the brightness peak, or around 3,700 miles. Note that the dotted red circle marks the distance scale. Each panel displays the date, the starting and ending UTC times, and how many observations were stacked. The arrows. The red arrow indicates projected velocity direction. The yellow arrow signifies the anti-OLA direction, meaning directly away from the sun. The orange lines illustrate the determined projected rotation axis direction. Meanwhile, the yellow lines trace the regular tail direction, and brightness contours are represented as pixels intensities ranging from the 20th to the 95th percentile. The anti-AL is this narrow, linear dark feature extending roughly northwest toward the sun. Now, let's revisit what transpired before perihelion. The earlier alignment holds significance from before perihelion. However, after perihelion, which occurred on October 29th, new images from Hubble and various ground-based telescopes still show the notable anti-tail jet oriented towards the sun. This remains observable in the most recent images from December 15th and 16th. Here comes a critical complication. As you might realize, after perihelion, the object is receding from the sun, correct? And the same side that faces the sun is not the same as the side it was initially facing, which makes sense, right? When it was approaching in July and August, the side that now faces the sun was the night side. Thus, the jet base that instigated the anti-tail back in July would now be positioned on the night side, non-operational. If you maintain the assertion that this is a natural comet comprised of ice pockets, then a new ice pocket must be located near the opposite side of the pole as well. Not only that, you would have to posit both that there was activity on one side and now there's another instance of it on the opposite side, leading to a new sunward anti-tail post-perihelion, while the previous active region must have shut down. This constitutes a truly anomalous scenario, very peculiar. We can define this as the second power. So what does the second power probability entail? Here comes the mathematical punchline. Harvard professor Avi Loeb states the new anti-tail remains columnated within an 8-degree span, extending up to 500,000 kilometers based on the latest images from December 15th. We discussed this previously. It is extensive, about 310,000 miles, bigger than the distance from Earth to the Moon. I've mentioned this in earlier videos as well. Thus, this columnation, as it's termed, combined with this unusual geometry, identifies it as a new anomaly. This means we need two separate favorable alignments, which fortuitously occurred. What a remarkable coincidence! One ice pocket would be near one pole for the inbound phase, and another near the opposite pole for the outbound phase. How coincidental is it to find these jets at both locations? I'm not sure, honestly. What we do know is that each alignment carries a probability of 0.05. Multiplying both gives us a squared probability of 0.0025, or 0.0025%, which is staggeringly low, effectively about 1 in 40,000 chances that this could transpire with a standard natural comet. Let's also touch on the comments regarding spacecraft made by Avi Loeb, which have garnered significant media criticism. I genuinely don't comprehend this backlash because if NASA were to clarify these 14 to 16 anomalies, we would feel better about it. Yet, they choose not to mention these at all, simply labeling it a conventional comet booster without addressing the anomalies or offering explanations. Avi proposes that a technical spacecraft might have a rationale for aligning gas emissions from thrusters towards the sun. However, he also stated that unfortunately, we lack high-resolution images of the jet's direction near perihelion. He does not claim definitive proof but rather posits that this geometry would fit a spacecraft model, and until we acquire decisive imagery, we cannot verify this. Why is this columnation so perplexing? The fact that these jets remain tightly columnated out to 500,000 kilometers, about 310,000 miles, is truly remarkable, especially considering the solar radiation pressure and solar winds acting upon it. Particularly after perihelion, one would expect the jet to be pushed and to broaden, yet it remains sharply directed towards the sun. Therefore, some key questions arise. Why does this sunward jet remain narrow? Why isn't it spread out or repelled by solar winds? What are the jet velocities and mass loss rates? We hope to learn more about these details with spectroscopy, right? A spectroscopy of the jet material may hopefully clarify how the antitail is formed, potentially providing another answer. Additionally, we discussed the rotation time of every 7.74 hours. Previously, it was believed to be every 15 to 16 hours. Thus, the 7.74-hour rotation schedule may imply the actual nucleus rotation is double that amount, around 15.48 hours if there's only one active spot at a time. This would correlate with the rotation period deduced from brightness changes seen in July, which indicated it was 15.16 hours. The figures seem to align rather well, as some of you queried after my last video about the cause of this change. The nucleus's radius is still estimated at approximately 2 kilometers, or 1.24 miles. Given a rotation span of 15.5 hours, let's compute the centrifugal acceleration at the surface, resulting in approximately 0.000025 centimeters per second squared, which is extremely tiny compared to Earth's gravity 1g, around 2.66 millionths of Earth's gravitational force. Abby Lowe presents an interesting point regarding the artificial gravity aspect. If one seeks to generate artificial gravity akin to Earth by spinning, a remarkably short rotation period of about 1.5 minutes would be necessary. Thus, the current spin rate of 3I Atlas doesn't produce an impactful level of artificial gravity. In summary, this new paper discovers that the small periodic wobble noted in the antitail direction indicates that the jet source is near the spin pole within 8 degrees, suggesting that the rotation axis remains closely aligned with the sun's direction, even at significant distances. The random chance of this occurrence is merely 0.5%. Following perihelion, the continuing visibility of the antitail sunward indicates a second favorable polar ice pocket scenario if we maintain the comet hypothesis, ultimately squaring the probability to around 0.0025%. Consequently, the jet remaining narrow over a distance of 500,000 kilometers raises serious questions about how it maintains collimation against the forces of the solar environment pushing it in the opposite direction. Spectroscopy could hopefully clarify the mechanism. Predicted rotation period estimates appear broadly consistent at between 15 to 16 hours, but the spin rate remains far too sluggish to generate Earth-like artificial gravity. We'll have to wait for more insights, folks. While I have more exciting information, I don't want to make this video excessively lengthy. So please subscribe, like, and share. And if you feel inclined to support me with a coffee, you can find the link in the description below. Don't forget to check out the videos displayed on the end screen, and I encourage you to explore my playlist dedicated to 3I Atlas.